Somebody's having my camera. I wonder if somebody was messing with my camera. White balance is all crazy. Tint also says 16. It's very strange. I wonder if somebody touched my camera yesterday. That would irritate me, but it would definitely be possible. Because sometimes kids are stupid. And by stupid, I mean like entitled and think they can do whatever the heck they want. But not all kids and not all times. Bro, are you trying to fight me like for no reason? That's crazy. You know I love you and care about your life. Yeah, okay. You're a burger. Or are you a booger? Okay, up and going. That was belabored. Okay. Numero. What? What did we do? 2 through 16 evens. Number 2, about 156 miles. Number 4 is you'd have something like 1 inch equals 4 meters, and you'd have a rectangle that is 2.25 inches by 4.5 inches. You could also use centimeters or something like that, I think, if I'm not greatly mistaken. What is number 4? Choose appropriate, yeah. Yeah, so you could use centimeters. They do stuff in inches, but whatever. You could answer it that way. Number 6 is 280 kilometers. Number 8 is 153 kilometers. Number 10, 1 inch to 1/4 miles. That's 10A. 10B is 1 over 15,840, and the explanation could be something along the lines of the map distance is 1/15,840th of the actual distance. The actual distance is 15,840 times as long as the map distance, something along those lines. Number 12, you'd have a rectangle drawn, labeled something like 1 inch equals 8 feet, and you do a 6.25 inch rectangle by a 10.5 inch rectangle, something along those lines. Number 14, how long will it take to drive from Gainesville to Miami, Florida, traveling at 70 miles per hour? 16, 17 feet to 23 feet. What questions do you have on those? Number 14, how long would it take to drive from Gainesville to Miami, Florida, traveling at 70 miles per hour? So we got our picture. So mine, because it's shrunk to fit the answers on the side. I don't have the right measurement with a ruler, so you're gonna have to tell me what you measured. Hey, so what did you measure? Oh, what happened? My thing went nuts. So tell me what's going on. Is tithing biblical for Christians? Sort of. Is the best answer you could give. I don't know what Wes Huff would say about that, because I haven't watched his video. I don't know if I will watch that one. Okay, inch and a half, that sounds long.
Well, that's what.
From Gainesville, to Miami. Well, you have to kind of go like this and then this other. So it's an inch and a half from, Gainesville. Oh yeah, inch and a 3/8 plus, is that what you did? Oh, plus 7/8. So 3/8 plus 7/8 is 1. So 2 inches-ish. is about what's measured going on the roads that are pictured. So we've got 2 inches measured. What? I did on the answer. Is that what you said? I said, is that long? I didn't say it was. That's crazy. Okay, so 1.5 inches. And what does our scale say? Excuse me, not 1.5 inches, 2 inches. So what does our scale say? 1 inch equals 200 miles is what the scale says. So if we measure 2 inches, what do we need to do to figure out how many miles? It's just 400 miles because it'd be this times 200, right? 400 miles. Okay? So 400 miles. It says, how long would it take to drive from Gainesville to Miami, Florida, traveling at 70 miles per hour? So the formula, we've talked about this formula many times in math, that you kind of need to know is distance equals rate times time, right? Now, it's worth noting that we can get this formula just from the units, because miles per hour, right? Miles is which one of these? Distance, rate, or time? Distance. That's distance. Hours is what? Time. So this is the rate. If we divide by time, the rate equals distance over time, right? That's because that's how the units work, right? So we got D over T. So we're given a rate of 70 miles an hour, right? So 70 miles an hour, we want to know how long it would take to go a distance of about 400 miles, right? So what do we do to solve for time right there? Divide by 70. Oh, is that what you said? That's crazy. That's burgers. Oh, that's like 1/4 of a burger. So it's 1/4 as good as burgers. Oh, it's bad. Oh, so buns with no burger is bad. It's kind of like a cowboy with all hat, no cowboy. That's kind of what we're saying there. What's 400 divided by 70? 5.7. What units? Hours, yeah, because it was in miles. This is in miles per hour, so hours is the time unit. So that's about what it would be. Now, we didn't quite get the same as what the book got. Our measurement was a little bit different. Just because I'm curious, if you put your ruler just on the dot of Gainesville and you put it in over to the dot of Miami, how far is that? Okay. Do you agree, Gavin? You check too. Brother, here. My ruler's gone. Katie took it. Ow! I'm dying over here. Too much crap in this room. You're a burger. He said about 1.5 inches. Yeah. About 1 inch. So we did 1.5 inches. That would change this to 1.5 times 200, which is what, 300, right? So what's 300 divided by 70? Just because I'm curious to see whether this is closer to what the key said. 4.28. They said 4.1. So they somehow thought that they were a crow and were flying straight there. That don't make no sense. Our answer's better. Yeah, huh? What? Our answer says we would get there in 5.7 hours. Their answer says we'd get there in 4.1 hours. We would be disappointed if we thought we were going to get there in 4 hours, but it actually took 5 hours. And then you've got screaming kids in the car. You got to stop and let them go pee-pee and buy a Coca-Cola from the place. And then it takes like, should have taken 5 hours, but we thought it was going to take 4 hours, but it actually took 12 hours. OMG, that would be too much. POV Google Maps. I don't know what you're saying, bro. They're trash. No, they're not. You didn't live through the days of MapQuest and printed maps. You even further back, you didn't live through the days of just having a map and having to be like, okay, I gotta go this road, and then you had to hold these couple of roads in your head, and if you forget, you had to pull over and be like, okay, where do I need to go? What's happening? You don't even know, bro. Yeah, you have a skill issue. You don't even know how to read a map. Brother. Is that why you got lost in the woods that one time? That's crazy. Okay, what other questions from this lesson do you have? Josiah Fulgerson submitted late. Bruh. You're trying to do a school. Good job. Okay, so do we have any questions from the study guide then? Yeah, just all of them. Yeah, that's right. Is a proof. I said that. Remember, there is a proof on the test. After this unit, the next unit doesn't have any proofs. Yes, it doesn't. It doesn't have any proofs in the next unit. Yes, that's correct. Number 10 from the study guide. Just for fun. That's a good one to do. It's got some crazy proportions happening. So that's a good idea. I like it. Let's do it. Oh my goodness. 9 over. I'm about 98.5% sure that this is just allergies, which would make a lot of sense because I played outside. Well, I didn't really play much, but I was outside in the dirt yesterday evening. So it makes a lot of sense that it'd be allergies. And I really hope I'm not getting sick because I don't want to get sick. I ain't got time for that. I gotta say, what the burger? What the burger? Okay, what should we do to solve this proportion? Cross multiply. I agree. So what's that gonna look like on this problem? What's that gonna mean? You gotta swoop, swoop. Yep. What's 5 times 3x? True enough, 15x. What's 5 times 9? 45. No, that's 5 times 8. No. Actually, in some contexts, yeah, but not in this one. Okay. What's 12 times x? 12x. What is the what? A second. That's crazy. What now? Subtract 45, sure, that's fine. Now what? By what? We can do that now if you want. Okay, so how do we took in the 12 over? Subtract the 12x. What's 15x minus 12x? What's 15x minus 12x? Definitely not, bro. Look again. 3x. Same. Nope. Now what? Divide by what? True enough. So what does x equal? 15. So close and yet so far. No. Negative 15. True enough. All right. Y'all look through the study guide, find anything else that you want to take a look at. I'm going to get some water in the vain hope that that might help my allergiesness. Rinse me out or something. Or something. Great googly moogly. You ready for your test? No. Oh, I am, because I remembered to print it. It was running late, but I did remember. Whew. What? Last year. If you say so. All right. What other things do you see on the study guide? 24 oceans. Bro, are you becoming a brain rot kid? It's a walking app. I see. Is that what you and your friends do? Walking apps? Basically. I think it was Ruth. All right, we got a couple triangles, got some parallel sides. We need to solve for x. We know that there's similar figures involved because we're smart geometry students. What proportion can we write? Not necessarily. That's not really how it's written in the theorem. You could probably rearrange it to work that way. That one doesn't quite make sense. Yes. Okay. I get where, okay. So, You don't cross multiply to write the proportion, you cross multiply to solve the proportion. To write the proportion, you put this goes with this. And so let me talk through a couple things. One, there's a theorem that says this to this equals this to this. If these are parallel, right? If we're in this sort of structure, right? So that's true. Also, we know because of angle, we know that this triangle is proportional to the big triangle. So we're not going to do it the long way because we have a theorem to do it the easy way. We could write x, I'm going to write this over here, don't necessarily copy this one down, but we could say that's x to the big side, which would be x plus 4, right? That whole thing. And then that would equal the little one, which would go with 12, to the big one, which would be 5 plus 12, right? So we could write that proportion and we would solve it, we'd get the same thing. However, we have a theorem that makes it even easier. When we have a setup like this, we can say x to 4 equals 12 to 5. So that's an easier proportion. They both theoretically get us the right answer, right? But to solve that easy one, what do? Cross multiply. What's 5 times x? 5x. What's 4 times 12? Not 64. What? That's 12 times 12. With 4, it doesn't jump past them both, so 4 times 1 is what? 4 times 1 is what? 4, correct. So 4 times 2 is what? 8. So 4 times 12 is 48. It's once we get to 12 times 5 that we have to start to get a little bit more confusing, right? Because it's 5 times 10 is 50. And 5 times 2 is another 10, so we jump up over and it doesn't just like line up evenly. But 4 and below is easy with 12s. We just do just a thing times 1, thing times a 2. We got this, right? So 4 times 12 is 48. What now? Divide by 5. X equals what? 9.6. Just for grins and giggles, this should probably work as well. What's 5 plus 12? 17. So we've got 17x from this cross multiply. This one you got to distribute. What's 12 times x? 12x. What's, excuse me, 12 times 4? 48. We subtract 12x. And we get 5x equals 48. Now we're at the same place. You'll see it does work. Cool beanie weenies. What other things from the study guide do you see that you'd like to look at? Just in case, 30. Okay. Term 27 instead. Okay. Because it looks crazy. I bet we're going to use a proportion to solve it. What do you think? But the trick, of course, right, is writing the correct proportion. Once you have the proportion, it's easy. Cross multiply. You know that. you got to study the theorems. What? Yep, there is one proof on this test. If you fail it, it's going to be fine. Well, it depends on how much you fail the proof. Then you should be fine. That's probably true. That doesn't mean you shouldn't study the theorems and the proofs, because the theorems will help you solve this problem. Because the theorem will help tell you what's proportional to what on this problem. So we need to know how these guys are related. We got an angle bisector up there. How do I know it's an angle bisector? Yeah, because of those little angle marks, right? Well, there probably is a triangle that has angle-angle similarity, but I don't know where it is. Right there, bro. So that might be helpful, and that could be a useful way to think about what's happening, but I don't know that that's the most useful thing. Got angle bisectors happening. So what theorem could relate some of the segments? What? Which one? So let me ask you a question. This is like one of those stupid Facebook things that you see floating around or whatever else. How many triangles are in this picture? There's more than that. No, that's a good guess, just because of how math often works. No, there's not an infinite amount of triangles in that picture. There's, oh gosh, I almost died. There's 3. Where are the 3? The 2 small boys and the big boy. That's right. There's this guy and that guy and these guy, the chunky one. So, which ones are even similar? That doesn't make any sense. Yeah, but that's not what similar means in this context, bro. Okay, so the small boys are similar. They definitely don't look similar. That doesn't necessarily mean that they're not. So on a picture like this, especially if you can't quite remember the theorem, right? Especially if you're coming in there and you're like, okay, I know that these are related somehow. I know something is going on. I know something's happening, but I can't quite remember the theorem. My brain is a little bit broken and I'm not quite sure. What I think can be useful is to separate the 3 triangles and see if we can get some things that are separate. So I'm going to grab this little triangle to start. I'm also going to put some letters on here. Let me put some letters because it's going to be easier to see what angles and what things go together. So let's label this A, B, C, D. All right? So let's pop out triangle ABD. So we got triangle ABD. What can we label from that picture on this triangle? 8 is this side. This side is X. And this is congruent to something we haven't drawn yet. Okay? So let's get the other little triangle. So let's get triangle BCD in there. So we got this long looking leg. We got this leg, which exists with this one. So we got a couple of congruent things because they're the same, reflexive property and all that. D, and this is C. this is 10, and this is angle, right? So right now we have angle with the blue triangle and the green triangle, not angle, angle. So far we don't got enough to say that those two are congruent. Let's draw the bigger triangle. Excuse me, bigger triangle. A, B, C. He has a length of 8 and 2 and x plus we don't know how much. Oh no. So what could happen? Do we see what this and thinking through this in this way, by the way, is a good example of proofs not being useless. And what I mean is that part of logic that we're working on being potentially useful, right? I'm going to let y'all go back to 7.5 while I go use the restroom real quick. I want you to look at the theorems, and I want you to, while I'm gone, I want you to see if you can find theorems that can help you. Also, I'll throw out there that if you look at example 5 on the study guide, it also has something that might be very useful. I shall return momentarily. 7.9 maybe. That is real close. That's talking about two different triangles. What? I did say N7.5. It's because that's what lesson that came from, right? Go back to the study guide and look at the little example 5 that it gives you right there. Triangle angle bisector theorem. Right? And it gives you an example of what that is. If you go to the very end of 7.5, by the way, on page 504, it gives you that same theorem in all the words, right? That's the theorem that we had in there. So triangle angle bisector theorem, we got angle bisector. We got a bunch of colored-y stuff, right? But what does the triangle angle bisector theorem say here? True enough. So if you look at that example, let me draw this on the board since different people doing whatever. The example gives you a picture like this, right? And it's got an angle bisector right there. It's got a Y, W, and an X. It's got an X right here. It's got a 12 right here. And it's got a 14 right here. And a Z right there, right? So the proportion that they're showing you to, because sometimes it's confusing when you read all those words. It's like, okay, my eyes glazed over. But if you look at the letters and you look at how it connects, then it's easier to be like, okay, it's this and this. So if you look at the example that they give you, this is a great way to study. Is to go back and look at these examples. Okay, this is a great way to study. To go back and look at these examples, make sure you understand how it comes from. So if you look at the example, they've got WX to YW. So WX to YW, so the two little sides. So this one to this one, right? This one to this one. WX to YW in this example, right? Equals, and then where does it go? XZ. Where's XZ? That's that one side. Now the XZ goes with this one, right? So the big sides, so this one would go with this one, right? To YZ, right? It's going to be the other side. YZ though? Wow. Okay. Right? So if you have angle bisectors, this to this equals this to this. Now, that's a bit tricksy because in the example, we don't have WY. We have nothing for that. Same for the problem we're trying to do, right? So that's a little bit tricky. What do we do with that? How do we figure that out? Well, we got to think about how segments work. The right side is easy peasy, right? We do have X. So let's kind of give us a start. So the sides, we've got 8 to 10. 8 goes with X, so we're just going to have X over here. We just got to figure out what to write right there. I think that's a 13. I wrote it stupidly. It is a 13. So it's not that, but we do use that. Right? Because like if we look at the example, we compare, it's not this to the whole thing, it's this to this one. So you're thinking right, it's not half though. You are thinking it's going to be a part, you're kind of on the right track. We don't really know what percentage it is, but we do know that if we take this 13.5 and subtract the X, we'll be left with this one. Right? So we could write that. we can write 13.5 minus x. Now we got a proportion. Now it's easy. We do cross multiply. X times 10 is 10x. Good, Granny Boat. What? Blessed beeth you. Okay, great. What's 8 times 13.5? Well, 8 times 8 is 80, so we're getting close to what you got. 8 times 3 is 24, so 80 plus 24 is 104. 8 times a half is 4, so 104 plus 4 is 108. So now it sounds right, doesn't it? Yeah. What's 8 times negative x? Negative 8x, right? What are you doing on your phone? What are you doing over there? What? Oh, you have your calculator up. Let me see. Whoa, it's pink. Okay. What now? Not subtract by 8 because we got it because it's negative, so we got to add. Add 8x. So we've got 18x equals 108. Now what? Divide sounds lovely. So we end up with x equals 6. 3.5 is not 6. What are you talking about?
108 divided by 8 is 3.5. 13.5. So we've got the same thing equals 8.
I see.
I have to look at
Okay, dudes, you should go. You should study. Please, do yourself a favor and study. I can't make you. But I can tell you that it'll make you have less stress come Tuesday. The sooner you start studying, the easier it'll be.